Hey, what's up everyone? Today, I'm diving into the world of text processing and pattern searching, that thing behind the scenes, making your searches smarter and your documents look cleaner. So, let's start at the top. What exactly is text processing? Basically, it's how computers read, analyze, and change plain old text like the words in your email's articles code. Think of it as giving your computer the ability to read and understand language, almost like a super-fast proofreader. Now, pattern searching is where things get really interesting. Imagine you're looking for a specific word or a phone number in a huge document. Instead of scrolling forever, pattern searching algorithms like the classic find and replace jump right to the info you need. They use something called regular expressions, basically, search patterns that can find, match, or even replace text all in a split second. But let's talk about line length adjustment. Ever noticed how some text lines in documents look weirdly long or short? Line length adjustment steps in to make your paragraphs look neat and easy to read. It automatically breaks up text so it fits perfectly in column screens, whatever format you're using. This is especially important in things like ebooks, websites, or even your phone's messaging app. Now, why does all this matter? First up, efficiency. With text processing and pattern searching, you can sift through massive amounts of data in seconds. That means faster search results, smarter spell check, spam filters that actually work. Plus, line length adjustment makes everything more readable, no more awkward line breaks or walls of text. Some of the coolest features? Automation is a big one. You can set up rules to automatically clean up data, fix typos, or format text exactly how you want. Flexibility is another. These tools work with pretty much any language or data type. And let's not forget accuracy. Pattern searching algorithms are super precise, so you only get the results you actually want. A quick bit of background. The roots of text processing go way back to the early days of computing, with algorithms like Knuth Morris Pratt and Boyer Moore making pattern searching crazy fast. Today, these tech foundations power everything from Google search to your favorite note-taking app. So, to wrap up, text processing and pattern searching aren't just for programmers or techies. They're the backbone of how we interact with information every single day. And with smart algorithms handling line length adjustment, our digital lives just keep getting easier and a whole lot tidier.
Introduction to text processing and pattern searching, text line length adjustment. Today's agenda. Introduction to text processing. Text processing. Text processing refers to the techniques used to analyze, modify, and format textual data. Turns messy words into meaningful and structured data. In the processing of textual information, the basic unit is a character. Efficient algorithms are needed for text processing. It is the art of cleaning, formatting, and analyzing text to make it readable, searchable. Applications. It's about converting human language into a format that machines can work with, breaking text into pieces, figuring out what it means and forms a pattern. This information is used in machine learning applications such as Voice Assistant, Apple Siri, Amazon Alexa, Virtual Assistant, chatbots, language translation, Google Translate, text summarization, spam filtering, sentiment analysis, useful for analyzing reviews in social media, tokenization, breaking text into words. Benefits. Efficiency. Automates repetitive tasks, reducing time and effort. Accuracy. Features like spell check and grammar correction ensures error-free documents. Flexibility. Allows for easy editing and formatting to meet diverse needs. Collaboration. Facilitates teamwork through shared document and version control. Accessibility. Cloud-based tools enable access from any device with an internet connection. Text line length adjustment. Definition. Text line length adjustment is the process of reformatting text so that no line exceeds a specified maximum character count, preventing words from being split across lines and improving readability. Application. This technique is vital for applications like text editors, document processing, and web design, ensuring a clean and user-friendly text layout. Example. Input. Flowers are beautiful with a 7-character limit. Output. Flowers, 7 characters, ARE, 3 characters, beautiful, 10 characters. Description. Setting the width of text lines to a specific number of characters to improve readability. The optimal line length for continuous reading text on desktop device is between 60 and 80 character per time. Algorithm.
Hey, what's up everyone? Today I'm diving into something that's everywhere, but you might not even realize it. Keyword searching in text. Whether you're Googling a recipe, hunting for a file, or sifting through hundreds of emails, keyword searching is the silent workhorse making it all happen. So why is keyword searching such a big deal? First off, it saves you a ton of time. Instead of scrolling endlessly, you just type a word, hit enter, and boom, you're right where you need to be. It's efficient, accurate, and honestly, it's the backbone of how we interact with information online. Let's talk benefits. Besides speed, keyword searching helps you find exactly what you're looking for, even in massive piles of data. It's used in everything from search engines, social media, and even in coding when developers need to track down bugs or specific functions. Plus, it's super scalable. Whether you're searching a single document or an entire database, the process stays pretty much the same. But how does it actually work? Let me break down a simple algorithm called linear search. Imagine you've got a long string of text and you want to find a keyword. Here's what you do. Start at the beginning, compare your keyword to each word in the text one by one, and keep moving forward until you find a match or reach the end. If you find it, awesome. If not, you know it's not there. It's not the fastest method for huge texts, but it's easy to understand and works well for smaller jobs. Of course, there are more advanced algorithms out there, like binary search or even AI-powered searching, but linear search is a great starting point. So next time you hit Ctrl+F or search for something online, just remember, there's a powerful little algorithm working behind the scenes to get you what you need.
Keyword searching in text. What is keyword searching? Keyword search is a method of searching for documents that contain keywords specified by a user, typically using a full-text search filter whereby a search term list is applied to a full-text index to find responsive files, or searching for documents containing one or more words specified by the user. Finding specific words or patterns in a text. Helps locate information quickly without reading everything. Forms the base for advanced text processing in computer science. Basic concepts and terminology. Keyword searching techniques. Different ways to find words in data efficiently. Ah, got it, sunshine. You want the definitions shortened for the PPT, so it's super clean. Here's a crisp version. Greater than C library function. Built-in C functions, easy. Greater than advanced algorithms, fast, handles large data. Greater than naive approach, simple, checks all text. Example. Brute force, naive pattern searching. Using Circa library, functions. Algorithm. Naive method implementation. Library function method. Expected output. Input. Hello world programming, world. Output. Keyword found at position 6. Real world applications. Document processing. Quickly find words in big files, like Ctrl+F. Content filtering. Detects coding keywords, if, while, etc. Key takeaways and next steps. Master the naive approach. Learn fundamentals before optimizing. Utilize library functions. Quick, built-in solutions for small data. Remember, efficiency matters when dealing with large texts. Always consider your data size and performance requirements when choosing an approach. Conclusion. Keyword searching forms the core of text processing. Different methods suit different needs, and the right choice ensures both accuracy and efficiency.
Hey everyone, today I'm diving into the world of text line editing, something you use more often than you think. Whether you're coding, taking notes, tweaking a document, line editors are behind the scenes, making sure every change you make happens smoothly. So, what exactly is text line editing? Simply put, it's the process of inserting lines, deleting lines, modifying lines within a body of text. Think of it like editing a paragraph in your favorite note-taking app or adjusting lines in a code editor. The core idea is to give you precise control over each line. Let's talk features: insert new lines, delete existing lines, replace text, search for words or phrases. Some editors go further: undo and redo, copy and paste, syntax highlighting for code. But it's all about managing lines efficiently, especially important when you're dealing with large files. Now, on the technical side, many editors use an array of strings to represent each line. Imagine a list where every element is a line of text. This setup makes it easy to access, update, or insert lines by their position. Let me walk you through a basic example workflow. Say you have a text file with 5 lines, and you want to insert a new line at position 3. The editor shifts lines 3, 4, and 5 down by 1 spot, then drops your new line right into the 3rd position. Simple, but super effective. So how would you code this? Here's a basic algorithm for inserting a line using an array of strings. First, check if your array has enough space for a new line. If not, you might need to expand it. Next, start from the end of the array and move each line 1 position down, all the way to where you want to insert the new line. Once you've made space, just pop the new line into the right spot. That's it. Here's a quick code snippet to visualize this. Suppose you have an array called lines and you want to insert at index I, for j from length of lines -1 down to I lines j plus 1, =sign lines, j, then set lines I =sign new line. It's a classic approach and it works great for small to medium-sized files. For really huge files, editors might use more advanced data structures, but arrays keep things simple and fast for most cases. So next time you're editing text, remember, there's a lot of clever tech making it all happen behind the scenes.
Text line editing. Text line editing project involves creating a program that functions like a line editor, allowing users to input, modify, and display text line by line. Features. Basic editing, text input and display, a scrollable area to type and view text, potentially with line numbers. File operations, save, open, and new file options to manage plain text files. Undo, redo. Implement a system to reverse or reapply previous editing actions. Text manipulation, cut, copy, paste, standard clipboard operation for moving or duplicating text. Find, replace, functionality to search for text strings and optionally replace them. GUI features, menu bar, for organizing commands like file, edit, and format. Font and formatting options, allow users to change font types, sizes, and possibly text colors. Technical aspects and implementation. Programming languages. Python, a good choice for beginners, leveraging the tkinter library for the graphical user interface. GUI. Java, another popular option, using the Swing library for robust GUI components. GUI libraries, tkinter, Python, or Swing, Java, are essential for building the interactive user interface. Data structures. You'll need to manage the text data, possibly using a std, string_view or std, string in C or a similar data structure in Python or Java to store the buffer. Algorithms. Implement algorithms for text manipulation, searching, and rendering the text on the screen. Example workflow. Start. The program starts, awaiting user commands. Command input. The user enters a command, such as add 5. This is a new line to add a line. 3. Execution. The program processes the command, modifying its internal data structure. 4. Output. The program provides feedback or displays the updated text.
Hello everyone. Today, let's make linear search simple. Imagine a messy pile of socks. You check each sock one by one until you find the blue one. That is linear search. Check each item in a list in order until you find a match or reach the end. We do it daily. Computers do it too, scanning lists to answer, is this item present? It's perfect when data isn't sorted. Start at the beginning and check each item in sequence. For small lists, it's fast, simple, and often the most practical choice. No special setup, no sorting, easy to implement and reason about. Use it when data is unsorted, when the list is small, or when complex setup costs more than the search. Think of it as the dependable workhorse of searching. It always starts at index 0, checks the first item, then moves to the next. No jumping around. Every element is checked in order, simple and predictable. Searching your contacts? The algorithm scans until it finds the matching name. In short, linear search checks each element in order to find if a target exists. Let's look at the defining features. Sequential by design, it proceeds in a fixed order, first to last. It never skips elements, unlike methods that jump across data. It works on any list, sorted or unsorted. No pre-sorting required, saving time and complexity on messy data. Best case, target is first, done immediately. Worst case, last item or absent, every element is checked. Time grows linearly with list size, O of n, tiny amount of code, a loop to visit items and an if to compare. Simple logic means fewer bugs and easier reviews. Use it when data is unsorted, when the dataset is small, or when setup cost is high. It's reliable, understandable, and a great baseline to compare more advanced searches. Now a quick demo. Find 19 in the list, 15, 8, 22, 19, 4, 10. Step 1, start at index 0, compare current item to target, 15 equals 19, no. Move to the next item, 8 equals 19, no. Next, 22 equals 19, no. Now 19 equals 19. Match, report, found at index 3. If no match appears, you reach the end and return not found. Pseudocode, for I from 0 to n1, if AI equals sign target return I, return -1, real world, an unsorted shelf. Start at one end, check each title in order. Halfway through, you find the target, stop, search complete. If sorted, you could jump around with binary search. But for messy or small lists, linear search shines.
Linear pattern search. Definition. A linear pattern search, more commonly known as the naive string matching algorithm, is a straightforward method for finding a specific sequence of characters, the pattern, inside a larger body of text, the text, or string. It is a brute force approach, meaning it tries every possible position for a match without using any advanced techniques. Algorithm for linear search. Thanks for watching.